Okay, in this problem we need to solve the differential equation by separating variables, and that will involve getting the dx over to the left hand side, so that gets all terms involving x on the left hand side and all terms involving y on the right hand side, separate variables, and then integrate both sides. That will give us the general solution, but that will be in implicit form, so then we'll need to get it in explicit form, which involves using the laws of logarithms. Once we've done that, we can then find a particular solution because we know the function passes through the point 0, 1. So I'll go through that step by step, a video for each stage, and you can try it for yourself and pause the videos at any stage and try and carry on. So first of all, let's separate out the variables. So if we write out the problem, xy equals 1 plus x squared dy by dx. So what I'm going to do now is get the dx over here, so shift the dx over to this side, and then all terms involving x, so that's this term, over to the left hand side, and then the dy will be over here, so I'll bring this y over there. And that will have separated out the variables, and then I can go and integrate it. So let's do that. So x stays on the left hand side. I'll bring the term 1 over at 1 plus x squared over, so that goes underneath 1 plus x squared dx equals, bringing the y over, it goes underneath the 1, so the inverse, in other words, the inverse of y dy. So now I have to integrate both sides, so I'm going to integrate the left hand side with respect to x and integrate the right hand side with respect to y. This one's okay, it's just the standard integral, but this one I need to let u equal this, use algebraic substitution. I know this is going to work because if I let this equal u, then differentiating x squared is going to give me 2x, and so the top has an x in it, so they should cancel out. Remember, we talked about when this particular method works, the numerator or the top of the fraction has to be in some way the differential of the bottom of the fraction, and then we know it's going to work. So for the left hand side, I'm going to let u equal 1 plus x squared, 1 plus x squared, and then I'm going to differentiate that, so du by dx equals just 2x, and then I'm going to rearrange for dx because I want to replace dx in the original integral, so dx equals du over 2x. So now I can put those values into this integral on the left hand side. So the left hand side becomes the integral of 1 over u times du over 2x, there should be an x on top there, should it's x over u, equals the right hand side integral of 1 over y dy, and that's going to be easy, that one. So now x has cancelled, and remember this has to happen for this to work, so x has cancelled out, so we're left with bringing the half outside the integral, 1 over u du, which is just the standard integral, equals the integral of 1 over y dy. So using our table of standard integrals, we then have that a half log u equals log y. Let's see. Taking the term involving y over to the left hand side, because we eventually want to have y on the left hand side, we have that log y equals a half log u, and then put the c over here, and also replace u with what it is, which is 1 plus x squared plus c. So that's our implicit solution. This is our implicit solution. It's solved, but it was not it's not explicitly in terms of y equals. So it's the implicit solution. General solution. So I'll stop that video here, and from the next video we'll look at how we turn that video, this solution, from an implicit to an explicit solution.